Welcome back, everybody. Welcome back to the channel. So today we're going to be finishing up the parser. We're kind of pretty much at the home stretch, and there's a couple things that we need to do to kind of just finish up everything. So let's just get right into it. First thing you want to do is you want to fix this bug. So I had a bug here originally where it actually wasn't with operator declarations, it was with method declarations, where if you parse the block, theoretically, if I go to syntax, you could theoretically, have a certain function called define foo, and you can just say a new class or something. And you could effectively put a statement here representing a statement as an expression because expressions are statements and not have the curly braces or the equal sign. So to fix this, I actually simplified the bug quite a lot, and there was actually a bug with the code that I had previously. So just do this. If you want to parse a block, we need to force the user to have a left curly. So if we don't have a left curly, we complain about it because parsing blocks do not enforce curly braces. So we just want to make sure that we enforce it at the compile method or parse method declaration level. So you want to do that for both cases, and that should be it. Also, I made this change to operator declarations as well. So when you parse an operator declaration, every time when you parse a block, because you have the same format here where you could have, the equal sign immediately after the function, so you can have an inline method declaration, just put this bug fix in or put this code in here where you just force the user to have a left curly to start the block. And of course, you don't consume it because this function is going to consume it. So there's that. Also, there's going to be a formatting change or a formatting update to constructors. So currently, constructors don't have a way to call the base constructor to initialize the class, and this is basically the format. So you have the name of the constructor, the error symbol, and then a naked U type, and then you have your parentheses here. So let's actually see how that's processed, and then we can get into finishing up the parser. So if we want to implement this, and actually I just made a quick change to it, so we'll see that change in a second. So if you want to support calling the base class constructor upon initialization of a class, then what you want to do is expect to see if the next token is equal to pointer. And if so, then you want to parse what's called a base class constructor. And what that's going to do is you absolutely need to add this feature in, guys, because otherwise, the language is not going to work. It's going to be pretty broken. So I highly recommend you add this. And basically, you just call the base constructor so you can initialize and set up that class. So if we go into here, we can see all you need to do is create an AST base class constructor, expect pointer, expect base, and parse your expression list. And that's going to be it. So that's that. Now let's finally finish up this parser. So we're going to go to parse statements, and we got one more statement that we need to process, and it's going to be absolutely it. What's the last thing we need to process? Well, that is when statements. Now, I mentioned before in my last video, we're not going to go over ASM statements. It doesn't really make sense to talk about that right now. So I'm going to hold off on that. If I were you, I wouldn't even bother doing this as well. In your programming language, this is a feature that comes much later on in the development of the programming language. You actually need a virtual machine in order to support this statement. So, all right, so the first thing we need to do is look for our when statement. So for when statements basically are a fancy way of processing switch statements. So I know the title of this video is going to be how to parse switch statements. That's not really what we're going to be talking about today. It kind of is. I think personally that when statements are kind of the future of coding in terms of like comparing data, because nowadays computers are pretty quick, so you don't really have to worry too much about your program being too slow, your programming language not being fast enough. Obviously, if you have a JIT and all these other things that we're going to learn, you won't really have to worry about performance issues. So what is a when statement and how does it differ from switch statements? So if we go to a traditional switch statement, so let's say we have a constant num is equal to 100. A traditional switch statement would you'd basically pass in a number, and you'd have to check for the case. For case of 10, then break or do something, right? And then you'd also have to check for all the other various cases. So I'm not going to put all of them here. You guys can kind of get the gist of it. And then we also have something called defaults. And what that allows you to do is just, it's kind of like a catch-all. It's like else in if statements. So if everything else fails, then run this default as your default operation. problem with switch statements is you can only do switch statements on numbers, which means that you can't do it on strings, you can't do it on you can't do it on anything else but a number. So I personally don't like switch statements, and I ripped it out of the programming language for the purposes of this YouTube series, and we're going to use when statements. That's something that Kotlin and Swift uses, and I really like how it works. So concept of when statements, we will have basically two ways of doing it. So we'll have what's called the where we basically pass a value of some value, and we say when this value is equal to this. So let's say 10, and if it's equal to 10, we do something. Otherwise, if it's equal to 100, do something else. And then finally, we have else, otherwise, as our catch-all statement. So this is kind of just like switch statements, slightly different. The benefit of this is now you can do this in switch statements as well. You don't actually have to you don't actually have to do the values individually. You can basically say when this number is equal to 10 or 100, then do the code that's in here. Otherwise, run the code that's in here. Now, here's where we get to the benefits. If we say constant name is equal to John, then we can also say name. So we can say name. Now we can say Jerry and John. Now we have the ability to basically compare strings using this when statement. When statements also have a second form where we can just literally say when this expression is equal to true. So we could say name is equal to John, or name is equal to Jerry. Oh, yes, I guess I mixed it up. So whether name is equal to Jerry or name is equal to John, do this, otherwise do that. So those are going to be the two main formats. We'll go over when statements a little bit later, but I think they're very nice. So let's just kind of see how they're processed. First thing you're going to want to do is create your is statement. When is the word we're looking for. Once you do that, you want to block access declarations. Obviously, that doesn't make any sense, and return true. Now, once you create your is or parse when statement, you want to create a AST when statement, minus minus the current token, parse when, and then you want to basically expect the when clause. Okay, so I actually didn't remember the syntax of this. So I guess when uses parentheses. So if we go back, so whenever you have like the case where you want to check for name, you want to say when, parentheses, when whatever value is in here is equal to this or this, those things. And it's always going to be or, it's never going to be and. So if you want to do like name or like, let's say num, right? And we want to say num is, less than 5 and greater than 10, or greater than 5 and less than 10. We could say num is greater than or equal to, let's do that, 5, and num is less than or equal to 10. So if it's between 5 and 10, then we can do that. Now, in this case, wouldn't really make sense to pass num in that value, because what we'd effectively be doing is saying if num is equal to 1 or 0. So in this case, if we want to do a comparison like that, then you'd have to just have the normal when statement with no parameter. And then you want to say when this condition is true or this condition is true. So if we go back, can see that we have our left paren, so we check to see if the next token is equal to left paren. If so, we expect left paren, parse an expression, expect the right paren. This is going to be expression that we're going to compare against, and as you can see, it's not required, so that's why we do a peek. And of course, none of these strings you need to add them to the branch, so you can just kind of block that. Now you need to parse what's called a when block. When blocks are a little bit more complex. It's kind of like if statements still. So you want to create a AST when block and expect a left paren. Then you want to have what's called a when clause. So you're going to want to basically parse a bunch of when clauses. So the first thing we're going to want to do is check to see if there's an else. Now, just like if statements, you can only have one else clause. So if we parse an else clause, then we just go to the end of the clause because we don't expect there to be anything else after it. So if we have an else clause, if the next token is equal to else, then we create a AST when else clause, expect else, expect the arrow or the pointer symbol, and then parse a block. Now, of course, since we're parsing a block, blocks don't require these parentheses here, so theoretically, you can put some expression here. I'm not going to write anything, but I'm sure you can imagine. Like you can put like an expression here and kind of just make this quick one line when statement. So that's also nice. So if once we parse our block, then we just go to the end of the clause, and at the very end, we check to see if we do not have a when clause. And if so, then we basically say expected a when clause. The reason why you want to do that is you don't want the user to just say when and then otherwise. That doesn't make any sense. Or if the user also did something like num, when num and then otherwise. Like that doesn't make any sense. You're not comparing num against everything. You're just instantly going to the worst case scenario for the when clause. So we just want to make sure the user has one of those available and we just complain about it. After that, we parse our left curly brace. So we're going to manually parse or the right curly brace. We're going to manually parse the when block ourselves because we don't really have any code or functions to parse that in our parser. So now this is for the case where we have like a regular when clause. So you want to create your AST when clause, parse an expression. This is going to be considered to be the condition expression. So this is going to be the expression that evaluates to whatever you're trying to evaluate to. So if you're trying to compare values or if you're just trying to check to see if an expression evaluates to true, then that's what we'll have. After that, we check to see if there's a comma. If there's a comma, then we expect that comma. And of course, you want to pass in when clause here because you want to make sure that if you get an error or something, then it'll be printed at the appropriate AST. You don't want to be using this branch AST because as we're processing these, it's going to get really complicated. You're going to be skipping over a ton of code because you're parsing blocks and stuff. So just keep that in mind. After that, you want to parse another expression. So that's how we are able to basically parse this expression, expect the comma, and then parse another expression. Once you're done parsing expressions because there's no more commas, then we come down here and we expect the pointer value and we parse a block. And that's it. So, and of course you don't need any of these tokens in here, so you can just kind of keep those out. And then finally, we check to see if the next token is not equal to the right curly brace. And if so, we go back up to the top of when clause, rinse and repeat. And we just keep doing that over and over again. So that's everything for that. So before we finish off parsing or finish talking about our parser, let's look at the final portion of parsing statements. So we've gone over a lot of stuff in this programming language, and we're about to start getting into some really complicated topics. I'm going to try my best to explain things as best as I can, but I don't want to drag on the episodes. So if I don't answer something or if you're confused, just definitely write them in the comment section below. But let's look at the final portion of parsing statements. So once you've gone through all of this, right? Once you've processed all of these statements, and if we still don't know what's going on, the next thing you want to do is support semicolons. So if the user like does, I don't know, they just put a bunch of semicolons, you want to complain about it. Now, obviously our compiler is kind of smart, right? It's not going to print the same error more than once, but depending on if they have aggressive error reporting enabled, then they will get multiple of these. But for the most part, they should only see one of these on that particular line. So we just want to complain about and say unnecessary semicolon. Of course, if they have access declarations, that's also not okay. So we want to complain about that as well. Finally, we have our label declaration and expression parsing, and that's literally it. If we've gone through all of this and we still don't know what's going on, like we're just going to return false. So if we look here, we've kind of already gone over label declarations, but I'll just briefly graze over it. You want to parse label declarations. You want to expect to see if there's an identifier, check to see if it's not a keyword, and if the next token after the identifier is a colon, then we want to parse our label declaration and return true. After we parse our label declaration, we want to, now this is where we get to the case where statements can also be represented as expressions. So first thing you want to do is enter protected mode. And once you do that, you want to check to see if the access declarations, if we have any access declarations, and you want to complain about that. Obviously, the user shouldn't be putting that right before an expression because that won't really make any sense. After that, you want to decrement the current token because expressions, as you know, always check the next token. And when you're parsing a statement, you're always inspecting the current token. So you want to back or put the token back one character so you can process it properly. If we don't process an expression successfully, then we, ignore it. We just pass the errors and we advance, free up the last sub, and we say not a statement. You don't want to complain to the user, because they're going to get some stupid error that's not really going to make any sense. So you just want to, like, if it doesn't work with parsing expressions, you just want to throw out any potential errors that were generated and just complain and say not a statement. Now, obviously, if it was successful, if you successfully parsed an expression as a statement, we fail because if there are any errors, we want to complain about it, and we expect a semicolon. Of course, you don't need to add the semicolon, and finally, we return true. So that's going to be it for parsing statements, and we are officially done parsing our parser. So the next episode that we're going to be talking about, I'm going to continue trying to do these daily videos. I'm not sure how long I'll be able to do them, but I'll do my best. So the next video we're going to be talking about is system requirements. This programming language has grown into a pretty big monster, and I'm going to be showing you guys how I set up my C-line project. I know it's kind of a little bit late in the YouTube series, but a couple things have changed, and I think it's a good point to kind of give you guys a quick update on that right before we start getting into the weeds with everything else. So, finally, as usual, let's look to see how all of this code looks. So, I'm going to go, well, actually, I can just do this. So, I'm going to case where I have just a blank when statement, and I just say when any of these conditions are true. So, I'm going to say I is equal to 1. Whoops. I is equal to 1, and just some random statement that I'm going to put in here. All right, so once we get here, or once the compiler kind of figures out what everything is, we have this printout of how our AST looks. So for when statements, we have this is the example where we do not have the value that we're trying to compare against. We just have a bunch of random if statements or random conditions to check to see if they're true. So we have a when block. We have two when clauses because we have the main when clause, then we have the fallback when clause, the else clause. So we have our expression of and expression, and I mean, you don't really have to see that. We've already kind of gone over how math expressions are working. So you guys kind of already understand what's going on here. But if I keep scrolling down, I can see we have, where is it? Okay, so we have our second expression. So if we scroll back up to the top, can see that we have, so in our when clause, we have one expression, then we have our second expression that we need to compare against, and that's going to be whether or not name is equal to John. After that, we have our block, which is just a variable declaration of I, assigning it to 1. And after that, we have our else clause, which is just an empty block. So now let's look where we have num. We can check to see if num is equal to 10. And let's just do, or 100. Let's just do a simple one where we don't really have multiple when statements. So that way we can just kind of see how things look. So we have our AST when statement. We have our expression. Now this expression is going to represent the num value, and that's going to be the condition expression that we need to compare against all of the when statements. Then we have our when block, where inside of our when block we have two expressions. So we have, so that's how we kind of detect or know the difference, right? This expression is outside of the when block. So obviously, if we have that, then we want to check to see if this is equal to all of those things. So in our when block, we have our when clause of an expression of literal 100. Then we have a block, which just is, again, a variable declaration assigning I to 1. Finally, we have our when else clause. So that's going to be it for today, guys. As usual, if you guys have any questions, definitely put them in the comments section below. And of course, if you guys would love to help support the channel, definitely head over to my GitHub repository at androidevcd/sharp. And when you do, definitely watch, star, and fork this repository. That's going to give this language a lot more visibility and let other developers know this language exists. Also, if you're curious about learning things that I've been up to in the language, just kind of on a day-to-day basis, as I push updates through, you can check out the commits in the remastered branch. And in there, I write some pretty wordy commits so you can kind of get a gist of what is going on without really having to look at the code. Also, if you're curious about maybe learning things that I'm looking to add to the language, or maybe stuff that I did in the past, you can check out the docs folder and that's going to pretty much contain all of the old stuff. So there's like two main files. So you can check out all of the old updates that I've done, which is inside of the change list, or you can check out the roadmap file, which is updated on a regular basis, where that contains not only stuff that I've already done to the language in the past, but stuff that I'm looking to add in the future. Definitely recommend checking out this file. It gives you tons of insight in the language. So that's going to be it for today, guys. As usual, if you guys are new to the channel, definitely consider subscribing, and until next time, I'll see you guys later.